All right, so today we have a solving practice. In our solving practice, we're going to do this first problem together, and then the rest of this you are going to do with a group or a partner, or by yourself, right? It's just practice. So remember, when you're going through this solving, things to ask yourself is, can I solve by square rooting first? If you don't see an x squared and an x, then you can. So for example, here you can solve number 2 by square rooting, but you cannot solve 1 by square rooting. For number 1, the next thing I'd ask myself is, can I factor it? So if it is factorable, remember you have to get it equal to 0 first in order to factor it. Then you look for a GCF. After looking for a GCF, then you look to see if it's 2 terms. If it's a difference of squares, you factor that. If it's a difference of cubes or sum of cubes, which we haven't learned yet, you could also do that. If it's 3 terms, you use your organizational X or guess and check or bottoms up, whatever you want to use to factor that. And then if it's 4 terms, we would factor by grouping. If it's not factorable, so like, no, it's not factorable, then we move on to completing the square or quadratic formula. So I don't always use completing the square. So for example, number 1 here, it's not factorable. I would complete the square though, because it's got a lead coefficient of 1, nice and easy to complete the square. But what if the lead coefficient, for example, is not 1, like this? Not a big deal, right? I could divide all 4 terms, both sides of the equation by 3, but nothing other than the first term is divisible by 3, so it just gets very fraction heavy. So I don't like completing the square for this. Instead, I would use quadratic formula. So as a reminder, here's what the quadratic formula is. It's x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And I like to put those in parentheses. In fact, I had it in parentheses before my video started, so that I don't lose negatives and I don't forget to multiply. All right, so as previously stated, we are going to use quadratic formula here, but let's run through why we are. Can't solve by square rooting because I see an x squared and an x. If I try to factor it, I'm looking for 2 numbers that multiply to give me negative 24 and add to give me 4. That's not going to happen. 1 and 24 doesn't work. 2 and 12, 3 and 8, 4 and 6, none of those work. So completing the square, not good, because dividing everything by 3 fractiony. So I'm going to use quadratic formula. A is the coefficient in front of x squared, b is the coefficient in front of x, and c is your constant. Using the quadratic formula, you have x equals the opposite of the b value, negative 4, plus or minus the square root of the b value squared, so that's 4 squared, minus 4 times a times c. A is 3, c is negative 8, all over 2 times a. All right, so now we're going to clean this up. We're going to clean up this number, which should always be positive, because it doesn't matter if this is a 4 or a negative 4. When you multiply it by itself, you get a positive. And then we are going to multiply these 3 numbers. This can be a positive or a negative number. So, and then also multiply those 2 numbers. All right, so let's clean this up. X equals negative 4 plus or minus the square root of 4 squared 16. Negative 4 times 3 times negative 8 is a positive 96, so this is plus 96. If this was a negative 3, then it would be minus 96, right? All over 6. All right, next I'm going to clean it up by adding these 2 numbers. X equals negative 4 plus or minus the square root of 112, all over 6. And now I have to simplify this radical. Now, if this radical was not simplifiable, maybe it was root 10, then I can just be done and leave my answer like that. The only thing I could do is divide this by 6 and then put this over 6, but that's not much prettier, okay? But root 112 is simplifiable. So I need the biggest perfect square that goes into 112. So my first thought is 4 goes into 112, 28 times. But 28 still has a perfect square in it. So I know that something bigger goes in. So then I say, okay, does 16 go in there? And 16 does go in there. Yes, 7 times. I didn't do that in my head. So if you want to know what I was doing in my head, I knew 4 went in there 28 times. And then this is 4 times 7. So 16 goes in there 7 times. That's what I was doing in my head. Okay. 16 goes in there 7 times. The square root of 16 is 4, so that I'm going to change that to 4 root 7. So I have x equals -4 plus or minus 4 root 7 all over 6. Okay? Now I'm going to clean this up just a slight bit more. If you look at this number, and this number, if those 3 numbers are divisible by the same thing, then you can still simplify this, okay? So -4, 4, and 6 are all divisible by 2. 2 goes in here -2 times, 2 goes in here twice, 2 goes in here 3 times. So you can write your answer one of 2 ways. You can write it as -2 plus or minus 2 root 7 all over 3. Or you can divide this by 3 and divide this by 3 and write it as x equals -2/3, because I divided the first term by 3, plus or minus 2 root 7 all over 3, or 2 root 7 over 3. So either one's fine. Like, I would leave it like this. Why extra steps makes no sense to me. Okay, so that's it to remind you what the quadratic formula is. So now go ahead and do the rest of these problems, and then you can come back and check it with the answer key that's in Schoology.